So class, our final thing to ask ourselves is this idea of making measurements based on how much light something absorbs. So far it's been things that you use instruments for, range from like $500 for a less expensive one, up to the ones we've looked at up to around $10,000, and there's certainly more expensive ones than that. So is this the kind of thing you could just do on your own? And the answer is kinda yes. And so what we're going to do is we're going to use a device that you have, most likely, most of you have, that actually has a light meter in it, and that's your phone. So I downloaded an app called the Lux Light Meter, and Lux is a unit used for how much luminosity there is, how much light there is. So this app reads the light hitting a light sensor in the phone. So the first thing I'm going to do is where's the light sensor? Where's it coming from? And so what you can do is you can run your finger over your phone until you see the light get blocked. And it turns out it's right at the top here. So right along here, if I do right along the top here, go along, right there. See that? It goes down. So there's actually there's a little, if you get the light on it just right, there's a little area right there where the light is blocked. So that's where my light sensor is, just to the left of the speaker right there. And so what we're going to do is we're going to make a little spectrometer out of my cell phone. Okay, so what we're going to do is we're going to do what's called a proof of concept test. We're not going to do a full-fledged investigation. We're just going to see if we can see a change in the light intensity using my phone's light sensor based on two different chemical samples. And our two samples are going to be simple. It's going to be some water and a solution of nickel nitrate hexahydrate that we've been using. But this one a little more concentrated than the ones we were using. So what we're going to do is we're going to add those solutions into a Petri dish each, because Petri dish has nice flat bottoms, which will give us a good, consistent interface between where the beaker is and where the phone is. The phone is wrapped up in a baggie, a sealing baggie, so it doesn't get hurt if I spill something. And we're not going to take a lot of time so it doesn't overheat. And there's a big heavy weight here that is going to keep it from moving. So when I was testing it, I saw if the phone just moved a little bit, it would actually change the reading quite a bit. Okay, so we're going to then, I'm going to get the samples ready and we'll see if we can see a difference. Okay, so now we're going to test our things. We have 30 milliliters of each sample in a Petri dish. So 30 milliliters of just water first, and we put that on here. The reading is around 3,900, 3,900, about almost 4,000, around 4,000, let us say. Okay, do the same thing with the nickel nitrate solutions. There is still 30 milliliters, so the same volume. And with the nickel nitrate dissolved, instead of around 4,000, we have 2,700. So roughly a third of the light has been blocked by the fact that we have nickel nitrate dissolved. So our proof of concept says, yes, you could make a spectrometer out of your cell phone. But you shouldn't, because it's dangerous for your cell phone. But at least you know it can happen.